Only constant at the top. This is not constant at the top. So don't shift up. And use quotient rule. And quotient rule, keep it as one term. Do you understand? Yeah. So this is the experience. I'm keep teaching you this so you don't have to wasting your time to get used to this method and then slowly no, this method is not good. You understand? Yeah. So constant at the top, then shift up. And when you use quotient rule, keep it as one term. We won't split the examiner expecting you have this answer. Okay. Yeah. All right. Copy this down and try to do I for me. So same situation. Is it difficult? No. Shift up, split, long division, or no? No choice. Quotient. No like that. Don't like that. You don't like that. We don't like that. No one likes that. Okay. So which means dy over dx. Make sure you times by 3. Yeah. U dash v minus uv dash. You can see visualize what's going on. 2 half become 1. You got 3. 2 times half is 1, yeah, and then you got a 3. So which means 3x over v squared. So this is the step that you finish quotient rule. Okay, but is it a final step? Of course, no. Because of what? Because you got negative indices in here. We don't like negative indices. So in front of you, you got 2 options to simplify. 2 options, 2 methods. Try to do it first your way, and then I give you another way. I will show you. That will demo 2 ways. They will end up the same thing, but one is faster than each other. The other one. Try first. Okay. All right. So basic algebra mistake. This one, first of all, these things, yeah, I don't want negative indices. I want a positive indices. So if I want to convert the negative indices to positive, we shift it at the bottom. But don't tell me you're going to shift this in here, right? That's crazy. Okay. This one cannot shift forward to the denominator because you got a minus in between here. You got 2 terms. Do you understand? So which means if you want to use this method, then what you can do, all right, I shift down to the denominator, but this is what I do. Yeah, I create a 3-layer fraction. And then what happened? I did mention that to you before. If you got a 3-layer fraction, the whole idea is make this as a single fraction and then you do a flip. Okay, that's what you should do for this method. Is it the best? No, but better than nothing. Just finish that. So which means the common denominator at the numerator is 3x plus 1 to the power of a half. And this is minus 3x. So what does that become? Bottom times what? Top times what? This is over 1. If you know what I'm talking about. So which means you got 2 times 3x plus 1 to the power of 1. Are you with me? Yeah. And then basically I can flip. I can write it down nicely. So this one I just write 3x plus 1 to the power of a half minus 3x. This one I can expand it in as well. 6x plus 2. And the denominator, 3 layers, is same as over 1, yeah? So which means times it by 1 over 3x plus 1. You understand? Yeah. So finally, combine together, your final answer will be 3x plus 1 to the power of this one is 3 over 2. This is 3x plus 2. That's how you get the final answer. Okay. Yeah. Is it the best? No. Can be better, as I told you. So you can see at the bottom, you got so many space. So you can write method 2. I just want to put it on the side to let you compare. I put a method 2 in here. Okay. You can write on the side. All right, look at here. What is method 2? Method 2 is called common factor. Just based on these steps. Okay, just based on these steps, can you able to see you got a common factor? They both have this. So which means this is much faster, much more appropriate. The common factor that I take out is 3 plus 1 to the power of what first? Can you tell me? Three x plus 1 to the power of what as a common factor? Like you got 3x plus 1 is positive half and negative half. Yep. Exactly. Always take out the smallest one. For example, 3x squared, take x to the power 5. I take out common factor is smaller one. Yeah. So which means negative half. So this is a negative, take out a common factor. This is the best way. All right. So have a look. What left over? The second term, no problem. 3x. The only problem is the first term. You got a 2 there. Original, you got 3x plus 1 to the power of a half. You took out 3x plus 1 to the power of negative half. What left over in here? If you figure out what left over in here, you're almost finished. So what left over in here? Think about that. This power, 1. Yeah, very good, 1. Because if I expand index law, negative half times it in plus 1, give you back half. Do you understand what I'm talking about? Yeah. How come this is much better? Because listen to this. Let me finish here. Just now I said that this cannot go down to the denominator. Why? Because you got a minus. You got 2 terms. But if I take out common factor, that becomes 1 term. So this goes straight to the denominator after. Much more faster. Okay. So which means that equal to 3x plus 1. And then this goes straight to the denominator, 3x plus 1 to the power of a half. And then left over, the top one, can I say 6x plus 2, take 3x. So which means same answer. 3x plus 2, 3x plus 1 to the power of 3. You understand what I'm talking about? Yeah. I keep saying that if you want to save time, it's not skipping steps. It's apply a proper method. It will save you a lot of time. If you don't apply proper method, you will waste a lot of time. 2 methods in here, method 1 and method 2. So the whole idea is quotient rule. After apply, how much further I should go? And what method can I apply to make it simplest form?